Hi, my name is Sumedh Chintawar, and this is my ME3210 Design and Manufacturing Project 1. My main product is a hydrophobic umbrella, which is designed as a frictionless, self-cleaning umbrella that aims to address common frustrations associated with traditional umbrellas, such as water retention and jamming. So this is just a general outline how my presentation video will go. I'll introduce the problem. I'll introduce the modifications that I made to the product, the different manufacturing processes that I'll be planning on using for the product, materials used in the product, advantages and disadvantages, and finally references. So my project is mainly focused on redesigning the umbrella to overcome two key issues. The umbrellas hold water a lot after use, and uh, and you need umbrella bags to carry excess water drip, and the excess water drip can make you or your belongings wet, and it's very uncomfortable to carry around after use. And also, due to water buildup on the umbrella, your folding mechanism can get jammed easily, which makes it very difficult for it to close smoothly. Uh, so I have a video here just showing basic CAD model. I made a 3D rendering of this hydrophobic exterior, and then also frictionless slides that help with the jamming. So the first modification, I'll expand on that, is the addition of nanomaterial technology to coat the umbrella's canopy. This coating repels water, allowing droplets to simply roll off the surface, which leaves the umbrella to dry almost immediately. This prevents users from having to deal with soggy, dripping umbrellas after use every time, which makes it a lot more convenient to use, store, and I guess just operate with. So here I have a computer generated sketch here on the left, and as you can see, the surface texture is drawn to make it look like there's a coating on top, with like carbon nanotube or some different powder that is attached to the cloth that makes it a lot easier for water droplets to run off. And this nanomaterial is very durable and maintains its effectiveness over time, even after multiple uses. And to expand on that, I made a 3D CAD model. And if you can see right here, the textured surface is supposed to represent how this hydrophobic layer can work on top of the cloth. It just very lightweight, seamless, goes on top of the cloth and barely noticeable until you're using it. And it represents like the material that we're supposed to use for the nanomaterial and hydrophobic coating. My second modification is it lies in these low friction joints and guide rails. The frame's pivot points are equipped with these plastic joints that you can see here. This is like a cross-sectional cut, which allows the ribs to move with very low resistance. This prevents, or I guess, it prevents the umbrella from getting stuck, especially when wet, and shows smooth operating and closing and opening almost every time. So in this video, we can see this red and black is the low friction guide rail, I guess, and it allows for a lot easier opening and closing, and it significantly improves the user experience, making it much easier to handle, even in terrible and heavy rains and bad weather. So the production um, and the manufacturing processes. So I'll be planning to use a hydrophobic nanomaterial coating application, which is mainly a nanospray deposition process. So this will help us achieve the hydrophobic properties of the canopy. So this involves spraying the fabric on top of the umbrella on the canopy with a thin water repellent layer, and this coating can be applied efficiently during mass production processes. For the second production, which is for the low friction guide rails and hinges, I plan to use high consistency plastic injection molding, um, which uses the injection molding process. And this allows for precise, consistent production of these small parts at a very high volume, mass production, ensuring proper quality across each unit. So these are the materials used for the product. For the canopy, I plan on using titanium dioxide, which is a very well-known material and molecule that is used for a lot of super hydrophobic applications. And it's been tested on different types of materials like cloth, fabric, polyester, and it shows very well conducive property of hydrophobicness and with liquids and water especially. I plan using aluminum alloy like here for the main frame, so the structure and durability is strengthened bad weather and heavy winds, and the low friction plastic for the guide rails, which will enable um, smooth movement between the frame and the canopy. So there are some advantages and disadvantages to this product. So the ease of use. So the frictionless mechanism ensures smooth opening and closing, especially in wet conditions. So there's no more struggling with a stuck umbrella day in and day out. And the water repellency. So thanks to the nanomaterial coating and the hydrophobicness of the titanium dioxide, which I described before, the canopy always stays dry, making sure the umbrella is more convenient to carry and store after use. There's no chance of you getting wet after the umbrella works, like the drippings after, so you don't have to worry about that. Also, using aluminum alloy or different carbon materials for the frame allows the frame to withstand stress and last longer than traditional umbrellas. However, due to this, there's a lot of more potential disadvantages. So, due to these specific manufacturing processes, the complexity increases, and it's going to increase production time initially. And due to all these different materials and the incorporation of hydrophobic applications and nanomaterials and precision manufacturing, this umbrella will be obviously more expensive than other traditional options. And these are my resources that I used. Did a lot of scientific research on the materials to be exact, and then a lot of manufacturing process guides. Thank you.